Welcome to part 5 of 6 in Analytical Geometry, and in this one we're looking at circles. There'll be 4 videos, and in this first video we're going to look at circles that are centered at the origin. Right, have yourself a Cartesian plane ready to go, and let's hit one example to start off with to get an idea of circles. It says determine the equation of a circle centered at the origin and passing through 4, 3. So we're in the middle of our circles here. We know that a circle looks something like that. Now, if you've got some sort of circular maker object, then make use of it. Otherwise, that doesn't look too bad, right? So there's our circle. Now, it says that it's passing through the point 4, 3. So 4, 3 probably looks like it's that point over there. So at that point, we've got 4, 3. Okay, now I think that the distance that that point is from the origin looks like it's about 5. Now, how do I know it's 5? Well, we could use kind of distance formula, 4 minus 0 squared plus 3 minus 0 squared. But let's use our dear old friend Pythagoras to go, okay, so if we had a right angle triangle, that would be 4, that would be 3. Well, we know that that's 5. In other words, the radius of the circle is 5. So to get the 5, we said, well, 4 squared plus 3 squared gives us the radius squared. Okay, and let's maybe pick out another point on the circle. So I'm going to remove that. You can leave it in your diagram. Let's keep that axis there. I was going to remove that point, but keep the circle and take another point in the circle. Let's say that our second point is up here, and this point over here is at 3, 4. That should still be on the circle, right? Because the radius is still 5. If we drew a nice little right angle triangle, we'd have, in this case, that's 3, that's 4, and 3 squared plus 4 squared still equals 5 squared. Okay, so we could keep playing this game for quite a few points, right? So let's pick some sort of other point. Maybe this point up here. Well, we know that that's 0. Y value? Well, y value must be 5 because the radius is 5. And this still seems to work. 0 squared plus 5 squared equals 5 squared. So we could do this with any point on our circle, any at all. That point down there, this point here. Well, this one here is at 5, 0. We've got a point maybe over here, which is at minus 4, 3. Well, let's just check. Minus 4 squared plus 3 squared equals 5 squared. Always seems to work. And that radius is always 5, because that's what's defining our circle. We've got a center and a radius. That's one of the key properties of a circle, is that you've got a center and the radius is always the same. So what we seem to be doing here is just we're taking our x value and squaring it, adding it to our y value that's squared, and we'll always get our radius squared. And that, lo and behold, is the general formula of any circle centered at the origin. So this particular circle's equation, this one over here, is x squared plus y squared equals 5 squared. So maybe we'll just write 25. So this circle's equation is this. Any circle has this equation. Okay, so that's the general formula for a circle centered at the origin. Let's do one more example in this video. Determine the equation of the circle whose diameter has endpoints minus 5, 2, and 5, minus 2. Remember, pause, draw your sketch, give it a go. So in this case, let's move back into that corner. And we've got minus 5, 2. And then this point here is at 5, minus 2. So let's label, or at least put the coordinates of these points. Okay, there they are. Now it said that this was a diameter. So I think that the center is going to be at 0, 0. Maybe just pause and convince yourself that the center is there, that it's not down here or somewhere else. Okay, my reasoning is, well, from symmetry I can see it, but otherwise that's a diameter, so the radii are the same. The midpoint of these 2 points, minus 5 and 5, 0, 2 minus 2, 0. So it's a circle that looks a bit more like an oval. It's a circle over here that is centered at the origin. So we know that x squared plus y squared equals r squared is the general equation for any circle centered at the origin. Okay, well, we need to work out what the radius is. Now, I think the easiest way here is probably just substitute this point in. So either one, I'm going to pick this one on the right, just is a bit closer. So 5 squared plus minus 2 squared equals r squared. Okay, 25 plus 4, 29. So 29 equals r squared. So the radius is square root 29, but our general formula is x squared plus y squared equals r squared. So there's our final answer. That's what the equation of that circle is. Okay, I'll see you in the next part where we'll start looking at circles that are not centered at the origin.